Good morning. So today I am going to present STL on topic matrices. So the question given is Along sends secret message to Busu in matrix form 4 times 4 dimension. So P is the real message that Along sends. So the task given is determine the correct message from K1, K2 and K3. So K1, K2 and K3 is the matrix that Busu has in order to find P from Along. So we need to help Busu to find inverse of K1, K2 and K3. The method that should be used is K1 Adjoint, K2 ERO, K3 ERO and Adjoint.
So as the first step, we are now have to find the inverse of K1 using adjoint method. So to find adjoint K, this is the method. So now this is minor first row, first column, and all of these are minors. So these minors will be changed to adjoint as I told before. So M minor first row, first column, in order to find that, we have to derive from the K1. So this is 121, 311 and 133. This is minor first row, first column, and we now have to find the determinant of minor first row, first column. So we have to use the sign pattern of cofactors for 3 times 3 dimensional, which is positive, negative, positive, negative, positive, negative, positive, negative, positive. So now positive 1 times with 3 minus 3, which is here. So we are now finding M11 here. So 1 times 3 minus 3 times with 1 and minus 2. Why here we are doing minus here is because according to the sign pattern of cofactors. So minus 2 times 2 times 3 times 3 minus 1 times 1, and then we plus 1 and then times with 3 times 3 minus 1 times 1. So it will give 0 minus 16 plus 8, and the final answer will be negative 8. So here, as we are doing for the 4 times 4 dimensional, we have to also consider the sign pattern of cofactors of 4 times 4 dimensional. So this is first row, first column minor. So we have to use the positive in order to get the final answer, which will also give positive negative 8 is negative 8. So now we have to find the inverse of K1 using adjoint method. So the formula for adjoint method is in order to find inverse of K, the formula is 1 over determinant of K and times with adjoint of K. So for example, adjoint of a certain matrix will be written in this way. So adjoint of x1, x2, x3, x4, x5, x6, x7, x8 and 9 to 16. So this will be written if in adjoint way. So the whole row will become a column. So the second row will become second column, and third row will become third column, and finally the fourth row becomes fourth column. So now we have listed the determinants of minors from M11 to M44. So now in order to find inverse, and the next step is we have to apply sign pattern of cofactors for every determinant of minors listed here. So the sign pattern of cofactors looks like this: positive, negative, positive, negative, negative, positive, negative, positive, positive, negative, positive, negative, negative, positive, negative, positive. So for example, we take row 1. Positive negative 8 will give us negative 8, and negative 5 will give us positive 5. Positive 34 will give positive 34, and negative 33 will give negative 33. So this application should be done for all the determinants of minors listed in the matrix form here. And then after we have listed, we have to change the K1 into adjoint K1, where we change the rows into columns. So this first row will be changed into column, second row will be changed to second column, third row will be changed to third column, and the fourth row will be changed to fourth column. So we will get adjoint K1. So we are now at the final step of finding inverse of K1. So in order to find inverse of K1, this is the formula: 1 over determinant of K1 times with adjoint of K1. As previously we have already find adjoint of K1, which is this matrix. So this is adjoint of K1. Now we have a variable which we haven't find yet, which is K1, determinant of K1. So how to find determinant of K1? So it involves the main K1 matrix and the determinant of minus we listed previously, which are not written in adjoint method, the basic method. So how to find determinant of K1? So the negative h should be times with 3 plus 5 times 2 plus 34 times 1 plus negative 33 times 1, which will give us negative 13. So negative 13 will be the determinant for K1. So we should insert the values into the formula, which is 1 over negative 13 times with the adjoint of K1. So the K inverse of K1 will be this, and in 4 times 4 matrix. So now, in order to find the message, we have to use P and inverse of K1. So P times with the inverse of K1 will give us the message. P given is this matrix, and we have already find K1 inverse of K1. So we have to do is times the both matrix. So here we are multiplying P matrix with inverse of K1. So how to do a 4 times 4 multiplication, 4 times 4 matrix multiplication? So for example, we take the first row and first column. To find the value for first row, first column of the product of multiplication is 93 times with 8 over 13 plus 50 times with negative 5 over 13 plus 78 times with negative 34 over 13 plus 137 times with 33 over 13 will give us the value for the first row, first column in the product of 4 times 4 matrix. So it will be to find the first row, first column value is like this. Hence, we have to do for all the values from first row, first column until fourth row, fourth column. So this matrix will be used to refer to the alphabet table in order to find the message that Along sent to Busu. So now we are going to find the inverse of K2 using ERO method. So before this we find K1 using adjoint method, and this is a different method to find the inverse of any matrix. So a basic steps to find inverse of K2 is this side should be the main matrix and the right part should be the identity matrix. So in order to find the inverse of K2, we have to do some steps in the left hand side main matrix to get to equate with this identity matrix. So basically it's like the identity matrix must be in the left hand side, and this part of after finishing the ERO, this part will be the inverse of K2. So there are 3 operations of ERO. First is interchanging 2 rows. Interchanging 2 rows is like we change R1, R2. It's like we bring row 2 to the row 1 and row 1 to R2. Or the next operation is multiply each element in a row by non-zero number. So it just involves multiplication of non-zero number with the row to get another value of another value of row. So we have to make sure all of these numbers should be 0 and these numbers should be 1. And thirdly, the third operation is multiply a row with non-zero number and add the result to another row. For example, so now we are multiplying the row 2 and we are adding row 1 to get row 1. So this is the method I'm gonna use to find K2 inverse. Okay, so this here, this is already 0. So now I'm going to make this 6 into 0. So this is row 4. And what can I do to make it 0? So as we are using the third operation, the 6 I'm going to minus with 3 times 2. So R4 minus 3R1 gives us the R4, row 4. So 6 minus 3 times 2, 6 is 0. 12 minus 3 times 4, 12, 0. 6 minus 6, 0. 6 minus 6, 0. So now we are getting the whole row as 0, and this is considered the inverse of K2 does not exist, because in order to continue the AR method, there should be a number in the row in order to get the identity matrix here. So since there is no number here, if we apply any of these operations, we won't get the answer, and the K2 inverse does not exist. Previously, we have calculated the determinant of each minus, all the minus. So these are the answers, and we have written in matrix form, which starts from M11 until M44. So now we have to apply sign pattern of cofactors, which is positive, negative, positive, negative, negative, positive, negative, positive, and so on. So by applying sign pattern of cofactors, we will receive this matrix. So I will show only the row 1 part of the row 1. So positive 4, 0 doesn't make change, and positive negative 12 will give negative 12, and the negative 4, so negative 4 gives 4. So these changes will occur throughout all parts, determinant minus of this matrix. So after we have applied sign pattern of cofactors, we can do adjoint of K3 matrix. So as I explained before, we have to just make the row as columns for every row as every column. So now we have to find determinant of K3. So we have K3, and in order to find determinant of K3, we have to choose any of the rows and multiply with the minus. So here I'm choosing the first row. So 1 times 4 plus with 1 times 0 and plus with 3 times negative 12 and plus with 4 times 4 will give negative 16. This is the determinant of K3. So the formula to find inverse of K3 is 1 over determinant times adjoint of K3. So 1 divided by negative 16 times the adjoint of K3, which we previously calculated, will give us the inverse of K3. So this is the final answer, which is the inverse of K3. So we are now at the final step. So P is the message that Along sent to Busu in matrix form, and K3 inverse that we calculated previously. So by multiplying P with inverse of K3, which will give the message to receive what message that Along passed to Busu in the wording form. So this is the method. P times multiply with inverse of K. How do we do it? We have to times the first row with the first column in order to get the value for the first row and first column. So the answer will be 1. The answer will be obtained by 93 times with negative 104 plus 50 times 0 plus 304 times 78 and plus 137 times negative 104. This method should be done for every row and every column, like 1 1 1 2. If we are getting the value of first row and second column, we have to multiply the first row with second column. So this must be repeated. This must be continued for all the values. And finally, the matrix we obtain after multiplying P with inverse of K is 1 for 17, 8, 11, 12, 20, 26, 1 for 12, 1, 0, 10, 19, 18. With this, we refer to the alphabet table, and finally we get the message, the real message, which where Along passed to Busu, which is Berilmu Berbakti.